Okay, so I want to rewrite this as t plus 1, t minus 1 over t minus 1. Yes?
Mm-hmm.
It's just a line. Now I know t can't equal what? What's the restriction in my domain?
2. Right?
1. But it's at t equals 3, which is why I'm allowed to do this. Because these two things are the same everywhere except for at 1 they are different. This has a hole, this one doesn't, but I'm not talking about 1, I'm talking about 3. So don't plug in 3. What do I need to do to this? Take the derivative. What's the derivative? 1. Plug in 3, I've already plugged in. That's this. So if I haven't, hopefully this is a good problem to convince you to rewrite things before you just dive in, okay? You have to think critically, contemplate before you calculate. It's the thing we'll talk about. Yeah.
Did you like do that with the quotient rule? Would you get the same answer?
Yeah, well I'll do it out on the board while you guys work. How about that?
Do we have to divide you?
It looks like time permits for you, so. Because
I have questions until like 4 o'clock comes.
Wait, are we doing no?
Yeah. Yes, you should finish this. It will not take you half an hour to finish this.
Are you sure?
I'm sure.
It might take me half an hour.
This?
With the way that my brain is going right now. I really yelled that too.
No.
I mean, what are you watching?
It's okay. Nobody's.
Yeah, you're right.
What am I doing with my life right now? Hold on.
Same thing.
These times
Did you work?
Listen here.
Well, run it off. How'd you get that?
How did you get that?
Oh, that is shitty.
So Gilbert,
Whoa.
I just did the quotient rule.
Okay. Oh, cool.
It's cool, right?
Here.
Where did you?
I just did the quotient rule to make sure.
That's
Yeah.
just check. That's make sure.
So if you had done the quotient rule, you would have gotten it.
X squared? 2?
But you would have wasted a lot of time.
Okay.
I plugged in.
What is sine?
So I plugged in.
pi?
So this is with variables, right? So you could
Zero.
do like
Negative
t
0.
minus 1 times
It's
2t
just
minus
0.
this times that. But I plug in the chart too. So I made like another chart. So t minus 1 is 3 minus 1, 2. So low is 2. It's way quicker. So look at how nice and
one of
neat
those
that is.
weeks.
Like simple and doesn't make your eyes go wonky. Now if you get t minus 1, 2 times 2t minus
I can just
t
get the
squared
college
minus 1
and then come
times
here.
1 all over
Really?
t minus 1 squared.
I guess.
I prefer
I'm
to
gonna go
write
just
this
so I can
than that. This is like, and also lots of mistakes
Even though like
all day long. So when you're plugging in a number, product rule, quotient rule, I always make a second chart to plug in, and then do low D high minus high D low over low squared with the numbers.
The business cards that they gave me. Email them.
You make fewer mistakes.
Two picks. Right?
Sorry. And then.
Where's one, Jen?
Yeah.
I think I'm wrong, but I'm always wrong, so whatever.
Oh, this would, it's very,
Three over.
What do you mean, 17? We just did that earlier.
Well, am I right?
It'd be sine x times cosine x plus sine x plus 2
I'm right.
It'd be 2 sine x cosine, right?
it's exactly,
It's different.
no, it's not, it's literally the exact same thing.
No, it's a different experience. Same
Cause did you get it wrong?
No.
Oh, I
So
did.
then how is it
I
the
read
same
it, right?
experience?
Because
Well, you
that
did it earlier.
happened. Now this is question 17.
I thought it was 4 to the 4.
So I could have gotten it wrong this time.
Oh, which is
I got it so wrong. I did the wrong product. I did the wrong rule. Did you do quotient rule? I did the power rule.
Rules.
They run together. So.
There's
They're
not
gonna
a
hear a bunch
star
of that.
in heaven that we can't read.
I don't gotta distribute then derive.
Yeah, we have similar stuff.
X minus pi.
How do you, what the frick? What is radical t times t?
Oh yeah, you have to distribute.
What do you mean?
I don't know what it is.
Distribute, then derive.
Yeah, what is it?
The 1
I'd rather us drive. So there's
1 over 2 root 2
distribute, then drive.
minus 2.
Derive. Oh, that sounds like drive. Derive and drive.
Derive.
No.
Drive.
Is that?
Drive.
And drive. Derive and drive.
So like 2 over the square root of 2. Is it just the square root
I
of 2?
feel like we sound like fools to the people watching the video. They can deaf hear me. Look how close I am to the.
It's like right there.
Hey guys.
So this is like. So this thing is.
Yo, what is t times radical t?
Because of the one that I have apple speak. I'll snack.
Wait, maybe I can do it to the product rule. Yo, after school, calculus hits me in a different way. I think I can afford this class. Would it just be negative
Time's
1?
freaking flying when you're in.
Alrighty, I'm calling it a day with this. I'm collecting them. Yes?
Did I have to
Do
finish?
I have my name on it?
No, because it says if, do this if time permits.
I didn't
So,
finish these two right here.
oh yeah, you gotta do this.
I got 6 wrong.
Can I transfer you tomorrow?
Yes, please. Yeah, yeah, that works. Or during class.
I'll just make your life easier.
Okay, I remember to do these for homework.
Did you finish it? Oh, okay. Different people then. Okay. So please take out 2.3b on the quotient rule. We're about to do some very big proofs / derivations.
Proofs bring me back to geometry class, and I was like,
I know, it's cray cray.
that was my
Wait, is this?
geometry made me just like that. So,
I like geometry.
yeah, because who was your teacher?
No, I have.
Mr. Clark.
Exactly.
Oh, really?
The shade.
Okay. So can you turn to this slide, please? Derivative of reciprocal functions. Okay. You can find the derivative of reciprocal functions. So, okay, we know there's 6 trig functions, right? We know the derivatives of 2 of them, sine and cosine,
Yeah.
which I just told you and kind of didn't do a proof, but like we explained it graphically and just believed it, right? So we're going to use those. You know how all 6 trig functions can be defined in sine or and or cosine? So we can, but there's like some of them are quotients and stuff. So between knowing the derivative of sine and cosine and knowing the quotient rule, we can derive them. Oh, so let's do the derivative of y equals tangent of x. I'm going to rewrite it. So flip. I'm going to rewrite this. Our theme for the day, rewriting. So we've rewritten through distribution. We've rewritten sine squared as sine times sine. How am I going to rewrite tangent? Yes. Oh my gosh, it's like all those identities are coming together. How, so y prime equals, that's what I want to know. How do I do it?
You do the quotient rule.
Quotient rule?
Yeah.
You ready to set it up?
Yeah. Oh, we ready?
Low equals,
Cosine.
high equals
Sine.
sine.
Wait.
And then negative finite.
Okay, so I'm going to let you just work on your own pace from there. Good.
Cosine. Cosine.
Yeah.
Cosine.
Okay.
Mm-hmm.
It's weird how cosine is negative sign instead of like. That's what I wait. How do you actually? It's like.
How am I gonna write cosine times cosine?
Cosine squared.
Cosine squared of x. Try to remember to put in an argument. If you forget, it's like not the end of the world, but you need an argument.
I feel like I just need to argue with people.
Minus negative sine squared.
Yeah. Right.
So plus sine squared.
Yeah. Oh, can you refer that to 1?
Big time.
Over
Over low squared.
cosine squared.
Wait, that's
Wait.
like.
But don't give it away in case other people.
But then that's like, what is it? Secant squared?
Yes.
No.
So pause right here. How's this?
No.
Good.
Do we notice an identity?
I sure
Yeah.
We sure do. The numerator I can make 1. Oh my gosh, you thought it was never going to pop up in real life. And here we are in real life, AP calculus class, and it's popping up.
Oh, that's another row. It's all
It's not real life. I know, it's still school. Not actually real life.
Bonkers.
So what is 1 over cosine squared?
Secant
Squared.
That's crazy.
So if I were to have told you the derivative of tangent is secant squared, you'd have been like, where did that come from? That's totally crazy and random. It feels random, right? But true story. The derivative of tangent is secant squared. You're gonna have to memorize this, okay? I use the memorize word very seriously and not often. This is memorized. Okay. Let's do another proof, shall we?
Yeah, now I'm actually kind of excited.
Cool. Let's do cotangent. You should be able to do this start to finish solo.
Congratulations. Can you speak on -1?
Yes, I can.
I can.
Because they both have a negative.
Never. I know.
So
Is it not?
Yeah, this is right. That's wrong.
It's negative?
Yes.
Oh, okay. Makes sense.
Okay, so is this an identity? So, yeah, no, it's not an identity as such. I can rewrite it though, rewriting my theme for the day, as an identity. What can I do to the top to rewrite it? Grace.
-1.
Oh.
Yes, Grace?
You factored -1.
Thank you. Okay.
Wait, were you raising your hand?
Yeah.
Oh.
Also, I didn't even pause between like the end of my question saying grace. Like I didn't even pause. Okay, so on the numerator, I get -1. Yeah.
Yeah.
Over sine squared x, which is negative squared x. So here's one way to remember it besides just like straight memorization. You know how tangent sine over cosine, it's got cosine on the bottom? So that's related to secant, you know? Because it's always low squared. So the denominator of a function and its derivative just changes because there's a squared on the bottom, but like if you start with a cosine on the bottom, you'll end with a cosine on the bottom, just cosine squared, right? And in this, you start with a sine on the bottom, so you end with a sine squared on the bottom. Like that's how the quotient rule will always work. So it makes sense that cotangent with a sine on the bottom will go to a cosecant thing going on. Okay, so the derivative of cotangent is negative sine 1 over sine squared. Alrighty, let's do secant. How are you going to rewrite this one?
Oh.
What is d high? Anybody can say it? 0. The derivative. The derivative of a constant is 0. Like constants go away to nothing. Okay. Do I need to write the 0? Yes, because I need the minus sign after it. Like if you're adding 0, like it doesn't matter. But if you're doing 0 minus something, like just make sure you have a negative.
Wait.
Yeah.
You with me so far? Okay. So let's simplify this one together to like the common form that it's normally seen. So sine x over cosine squared x. Anybody have any ideas how to rewrite this one?
Cosine times cosine.
Yeah, exactly. Sine x over cosine x times 1 over cosine x. So y prime equals tangent secant. Actually, oops. Everybody says secant first. You just say secant tangent. That's like how we're going to say it. I don't know why. Secant tangent.
Just like a tradition.
Tradition. So the derivative of secant is secant tangent. Again, kind of like out of nowhere, where did that come from? It's itself times another function. This is the proof. Also, how long did this take? I mean, 2 minutes, right? Probably.
Yeah.
You know, probably 2 minutes.
Guess you can check on the timer.
So, yeah. No, I'm just saying on the test, like if you were, or on a do now quiz, if you were to totally freeze and not remember it, it does not take long to do the derivation. It doesn't. Okay? So if you didn't memorize, this is the derivation. Like not a derivative derivation, but like, you know, like
the process of deriving?
the process of like a proof.
So are all proofs derivations?
Yeah, I mean, Yeah, some proofs are like, who cares what that is? But if it's like, this is a big deal, then I call this like a derivation of an identity. That's kind of like the difference. You only use derivation if it's like you're proving something that's like important. Okay, cosecant. I know, too many derivation for words. Alrighty, let's do it.
Yeah. Wait, I'm tripping.
You can memorize it.
Wait, you know how long it's like something squared plus 1 equals?
Yeah.
Is that are cosine, tangent, tangent together? Let's see if cotangent and negative. I had to print it out and then what happened? Cosine and negative, right?
Yeah.
Yeah, okay.
Oh, yeah.
But why is it printed like that?
Yeah, because the student,
Tangent.
the student versions have them. So basically that version. So you know how my version I press a.
Oh.
No, I know. Let me see.
Those are the problems.
There's still things that would like pop up.
Yeah.
So basically instead of having nothing there and then something pop up, it's there all the time with a white square over it, and then the white square goes away. Some of my PowerPoints are like that. Okay. Negative, cosecant, cotangent. It is negative, you got 0 minus on top. Okay? Right? Cool? All right, so we've now done them all. This is our summary page. All right, let's go.
Okay.
The derivative of, this means, what is the, like, take the derivative of sine, it's cosine.
I'm so glad I don't do sports. I'd rather have class than do sports. Shit.
Seriously.
No, because I have to watch a video to get all this.
I know, this would be way lamer.
Yeah, early in the year is kind
You know, this is.
of. You're learning everything in each course of the year.
Doesn't matter which one's in front.
It does not matter which one's in front. But I will write it this way every time for the rest of the year, so. Okay, let's make, once you have them all copied down, I want to make some observations to help you memorize them, okay? Or maybe you can make some observations, actually. Stare at these. What observations do you have? Observations. Do you know my old school, I couldn't make stars like that on the board because, like, the Bloods were a big gang. Yeah, I was talking about that. And, like, 5-pointed star is their symbol, so. Yeah, I, like, couldn't, this was like a gang symbol, like a star, so I couldn't do that. And it pulled from multiple neighborhoods. Most schools were, like, from a very small neighborhood that had, like, the gang of that neighborhood. But my school pulled from, like, a big area, so there was, like, multiple gangs all in school together. It was crazy. Totally.
She was starting turf war.
Yeah, I know. Okay, so this just is a star. What observations do we have? Half of them are negative. Which half?
Oh.
Yeah, the right half, but why, what about, like, what's similar between these three functions? Like, how are those?
They all cooperate with each other.
They all start with co, right?
Yeah.
So the derivative of all co-functions
Get my star.
is negative. Wow, that was like pulling teeth.
6
You guys couldn't see that? That was like, you didn't? No? No? Okay.
I'm better at being told things and figuring things out for myself.
Yeah, better being told. Means you're doing bad jobs
Does
as
it say
educators.
functions? The
Yes. Now, okay, I'm gonna give you another clue of what to look for. There's a relationship like between this one and that one, that one and that one, and that one and that one. Don't verbalize it, just think in your mind first.
But then Big Brother can get to
Just think in your mind. Anybody want to verbalize what they've noticed? All right, Denzel.
Sine, cosine are single terms.
Yep.
Tan and tangent and cotangent are negative, or they're square terms.
They both have squareds.
And then secant and cosecant are have two terms.
Sweet. Brian?
I was going to say that secant squared and negative cosecant squared are opposites.
Yes.
Like in every matter.
Like in every matter, right? So like let's say if I gave you this, if you've memorized that the derivative of tangent is secant squared, then the derivative of cotangent, you switch two things. You make it a negative, and then you add a co. Does that make sense? Like so, if you've memorized secant, like if you know the derivative of tangent is secant squared, then the derivative of cotangent, when I add a co in front, I have to co this. Like it's opposite, but I like how he said it even better. It's opposite in every way. Because this one, the derivative of sine has a co, the derivative of co like doesn't have a co, but it's like the opposite. By opposite we mean, of course, cofunction. So I guess the derivative, so derivative of a cofunction, the derivative of a cofunction is the cofunction of the derivative and negative. It might not be that helpful to describe it in words. Like I think it's just helpful to like see it and be like secant tangent, right? And then cosecant. Instead of secant, you're cosecant. Instead of tangent, you're cotangent. And then you're a negative, right? Because you're a cofunction. So you kind of need to memorize these three, and then memorize the rule that if you're taking the derivative of a cofunction, you make it negative, and then change the derivative to the cofunctions. So in theory, if you know the derivative of tangent secant squared, you shouldn't tell me that you don't know the derivative of cotangent. Should we go over it again? The thingies? Alrighty, cool. Alright, find the derivative of this.
Everywhere.
What rule?
One goes to
What rule am I going to use?
2 + 2 =
Product.
product.
Product rule. Great. Set up your product rule.
So this line.
Yeah.
It says it.
Yeah.
Okay, so now, here, we're not going to do the derivation again because we have memorized it. The derivative of cotangent, it's a cofunction, so my derivative is negative. Tangents, secant squared, cotangent, negative cosecant squared. So I'm not going to re-derive this, now I just know it, right? Like reprove it. Okay, you want to product rule it up?
Do That is crazy. Whoa.
We're done.
Look at the timekeeper. Does time
We're done.
permit it? Does time permit?
Can one person hold this, the other person not, and quiz each other on the 6 derivatives? Okay, and then you're gonna switch.
Okay.
All right, Denzel, Victoria.
Secant